All right, so let's get started. So we'll first discuss few of the statistics terminology that we have. So, all right. So first thing is like population and the sample. How do we define what is a population and sample? So population includes all the elements that we have from a set of data. So the whole data set that we have overall, we could define it as a population. And the sample is, we could say which consists of one or more observation that we draw from the population. So a population can be small or large as long as it includes all type of data that you're interested in. So, for example, if you're only interested in the exam marks of 100 students, the 100 students would represent your population. So, sample is as we could see from here, from the whole population, if you could take some few of the data from this complete population can be defined as a sample. All right, so how do we extract like from the whole population? We cannot directly just extract, for example, this word as I can take it as a sample. So sampling is such a technique. So where we should say that this sample is similar to the complete population. So it simplifies that this sample can be understandable from the whole population data set that we have. So there are different kind of sampling techniques that we have. So how do we extract, how do we make the sample from the whole population? So that if we do any kind of analysis from the sample, actually it should make some sense, which we could say that we could infer that the whole population is actually similar to this conclusion. All right. Then census and survey. So census is like the gathering data from the whole population. So we could say the elections or any 15-year census, something like that. So they can be considered as census data. So the survey is like gathering data from the sample in order to make any conclusions about the populations. Right, that is quite generic terms that we mostly hear or see in the newspapers, the census and the survey kind of data. So survey could be like opinion polls or like any kind of quality control checks in the manufacturing units. So those we could say as that we take a survey from the census. All right, then we have parameter and statistics. So parameter is a descriptive measure of population. So any kind of analysis related to population, we call them as a parameter. So for example, we have population mean, population variance, or the population standard deviation. So those are basically called as parameters. So anything that is related to population data, so we define them as parameter. And anything that is a measure of the sample, we consider it as statistic. So example of statistic is, for example, the sample mean or the sample variance, then sample standard deviation. So such kind of measures that are related to the sample data set, we call them as statistic. All right. So how do we denote all those parameters? So all the population related stuff parameter that we have, we denote is mu, then variance as the sigma square, and the standard deviation as sigma. Whereas for the statistic, we denote the mean as x bar, then variance as s square, and the standard deviation as s. So these are the basic actually the way how all the books or how the terminologies are actually denoted. So anywhere where you find that, for example, s square or s, so you should understand that variance is referring to the mean variance instead of population variance. So mu and sigma, all those are related to the population parameter, and x bar, s square, and s are denoting for the statistic sample. All right, so now we'll be moving to some important topic that we have, how the different sampling techniques. All right, so the random sampling, the first technique, if you see, so it is a process in which like each available member of the population are being sampled has an equal chance of being chosen for the sample at each draw. So the sample of this such results is called the simple random sample. So the sampling can be done with replacement in which the observations are put back in the population after each draw for the possible future series selection, or it can be done without replacement also, in which the case observations once selected would be unavailable for the future draws. So the data quality often matters more than the data quantity when making any estimate or the model based on a sample. So the data quality in data science involves the completeness or the consistency of the format, and the cleanliness and the accuracy of each of the individual data points. So the next another technique of sampling is stratified sampling. So stratified sampling is possible when it makes sense to partition the population into groups. So based on a factor that may actually influence the variable that is being measured. So these groups are then called as strata, and an individual group is called stratum. So the status, so it's stratified sampling. One should we could partition the population into groups. So this partition into when we do the partition of the population into groups, we call them as strata, and then we obtain a simple random sample from each of the group that we call it as stratum, and then we collect data from each of the sampling unit that was randomly sampled from each group. All right. So this stratified sampling works best when a heterogeneous population is split into fairly homogeneous groups. So the main reasons for using this stratified sampling rather than simple random sampling is, for example, this stratification may produce a smaller error of estimation than would be produced by a simple random sample of the same size. So this result is particularly true if the measurements within strata are very homogeneous. Then again, the cost per observation in the survey may be reduced by stratification of the population elements into any groupings when we do. Then again, the estimates of the population parameter may be desired for the subgroups of the population. So these subgroups should be then again identified. So for example, taking an example of this stratified sampling, let's say we consider the population of all the people in the US, for example. So we can make groups for all those such population that we have. So let's consider that we made groups 4 time zones in the US, for example, the Eastern, Central, Mountain, and Pacific. So based on the 4 time zones in the US, so we made, for example, groups. All right. So then what we do is we do this random sampling from all those 4 groups. So for example, we picked up 500 random people from each of the 4 time zones, right? So my sample would be 4 into 500. That is like the 2000 selected people, right? So from the 4 groups, I have randomly selected 500 people. So the total sample data set will be my 2000, right? So 4 into 500, we have the 4 groups and 500 from each of the groups, from each of the time zones that we sampled. So the 2000 selected data will be the sample data set. So another example, if we could say that, for example, we have let's say we took all the students in each of the local school district. All right. So now, for example, for all the students that we have in the school district, we made groups. For example, 11 different elementary schools in local school district. Now, from each of the elementary schools, we made, for example, from the 11 schools that we have grouped. So from 20 students from each of the 11 elementary schools have been sampled. All right. So my sample data set would be like 11 into 20. That would be like the 220 sample students. So what we did is from the whole 11 schools that we have grouped into, so the 20 students we have taken from each of the 11 elementary schools. So that is basically a stratified sampling. So simple random sampling, we could say that from the whole complete data set, we have randomly selected n number of guys. And then, for example, in the stratified sampling, whereas we are making the population into subgroups, and each of the groups must be homogeneous. And then from each of the group, we are doing some random sampling. So that is basically called as stratified sampling. So another technique that we have over the sampling method is cluster sampling. So that is quite different from stratified sampling again, but actually that is a little bit confusing when we see the stratified sampling or the name the cluster sampling, because in the stratified sampling also we are making groups and doing the sample from each of the groups, right? So in cluster sampling, what we are doing is we are dividing the population into groups again, but in this case the second step is actually changing. So over here, what we are doing is we are doing some sampling of the clusters only. So from all the possible clusters that we have. So, and then we are doing the sampling from each of the randomly selected clusters.
Can you please explain again this cluster sampling? Like what I got is in stratified sampling, we are dividing one entire data set into groups, and then we are randomly selecting some samples from each of the groups. So here, like, what is the difference here in cluster? What we are doing? I didn't got it.
Yeah, sure. So in this cluster sampling, I was just about to explain in detail actually. So in cluster sampling, what we are doing is, for example, the total number of clusters that we are making. So we are doing the sampling of the clusters only. So for example, we are making 10 clusters. So from the 10 clusters, for example, randomly I've selected 4 clusters. All right. So from the 4 clusters, all the data that we have, we are considering that is my sample data set. So compared to basically, even if you see the simple random sampling or the stratified sampling, so this cluster sampling has its own advantages and disadvantages. Then, so for example, given equal sample sizes, the cluster sampling usually provides less precision than either of the simple random sampling or the stratified sampling. So let me take the same example that we have did for the stratified sampling. For example, the all elementary schools, elementary students in a local school district is my population, for example. Now we made the groups like 11 different elementary schools in the local school district. All right. So among all the elementary schools that we have, so we made the groups of 11 different elementary schools, right? So now from those 11 elementary schools that we have, we made a sampling from those 11 schools. All right. So after sampling, for example, I've taken 4 elementary schools from the 11 possible elementary schools. All right. So now every student in the 4 selected elementary schools is my actually sample data set. All right. So I hope it is clear now. So in this one, the only difference is that, for example, in the stratified sampling, what we are doing is we are making groups, and after that we are doing the sampling, right? From each of the groups, we are taking the sample from each of the groups. Whereas in the cluster sampling, what we are doing is once we divided into the clusters, so we are doing the sampling of the clusters actually. So for example, 11 clusters that I said, so from the 11 clusters, I selected 4 clusters. Now all the data that we have in the 4 clusters are my sample data set. So so I hope it is clear now, right? So in the stratified, what we did is this from the schools that we have selected, for example, 11 groups that we made. So we made, for example, sampling from those 11 only. And from all those 11 that we have did the sampling, and that is my sample data set. Whereas in the clusters, we made the clusters first and did the sampling of the clusters only. And all the data that we had, for example, the 4 clusters out of 11 clusters we have sampled. So all the data that we had in the 4 clusters are my sample data set.
Okay, Abhishek. So we are considering all the data in the cluster sampling.
Right.
Oh, okay.
So in the stratified, we did the sampling after making the clusters. So in this one, we are doing the sampling of the clusters, and then we are taking all the data. So actually, if we see this elementary school example, so in this one, clustered sampling makes more sense than stratified. For example, if each individual elementary school appropriately represents the entire population, as in the school district where students from throughout the district can attend any school, then stratified sampling could be used if the elementary schools had different locations and serve only in the local neighborhood. For example, like one elementary school is located in the rural setting where the other in the urban setting, something like that. So where we have different kind of groups based on like that. So in that stratified sampling could have worked better. So for example, if the data where the population is, for example, any student can go to any school in the whole city, then in that case, the cluster sampling makes more sense, because the groups that we have in the cluster sampling is actually heterogeneous instead of homogeneous. All right. So these are the different sampling methods that we have. So mostly either the simple random sampling mostly works. Otherwise, many times stratified sampling, if we have different criteria of the groups, or we could make clusters. So in that case, stratified sampling actually works better sometimes. So the cluster sampling actually is rarely used in data science or while doing the cluster, and I mean while doing the sampling. But yeah, these are the important sampling techniques that you must know actually. All right. So again, this statistics actually we could say divide it into two kinds of descriptive and inferential statistics. So descriptive statistics actually do not allow us to make conclusions beyond the data we have analyzed or reach conclusions. So regarding any hypothesis we may have made. So they are simply a way to describe our data. So with descriptive statistics, there is no uncertainty because you're describing only the people or items that you actually measure. So you're not trying to infer properties about a larger population. So descriptive statistics are actually very important, because if we simply presented our raw data, it would be very hard to visualize what the data was showing, especially if there was a lot of it. Now, this descriptive analytics, this helps us to present the data in a more meaningful way, which allows simpler interpretation of the data. So, for example, if we had the results of 100 pieces of students' coursework, we may be interested in the overall performance of those students. So we also would be interested in the distribution or the spread of the marks, right? So in that case, for example, we would be going into, for example, the inferential statistics. So inferential statistics, what they do is they takes the data from the sample and makes inference about the larger population from which the sample was drawn, right? So because the goal of inferential statistics is to draw conclusions from a sample and generalize them to a population. So we need to have confidence that our sample accurately reflects the population, right? So that is the reason like sampling techniques is very important, because the sample data set that we have taken, it actually should reflect the population, the whole population that we have. Then only when we are doing any inferential kind of statistics, so for example, we say the mean of sample is, we could from the mean of the sample, we could say infer that the mean of the population is also could be similar to this, right? So that is could be, for example, inferential. So in that case, if the mean, the sample that we have taken is not similar or it's not reflecting the whole population that we have, then any kind of statistics that we are inferencing from the analysis, that would be actually wrong, right? So it won't be actually reflecting the whole population that we have. So, for example, you might be interested, for example, in the exam marks of all the students in the UK, for example. So, it is not feasible to measure all the exam marks of all the students in the whole of the UK. So, you have to measure for example, a smaller sample of students, let's say 200 students, right? So, which are used to represent the larger population of all UK students. So this inferential statistics are technique that allow us to use these samples to make any generalization about the whole population. So from which this particular sample has been drawn. So that is a reason like it is important that the sample accurately represents the whole population that we have. So this inferential statistics are also sometimes called as inductive statistics. So that actually means the same thing, that we gather the data from a sample and the statistics generated to reach conclusions about the population from which that sample is taken. All right. So in statistics as well, so it is important to recognize the different types of data that we have. So numerical or categorical and ordinal. So for example, if we ask 5 of your friends that how many pets they own, so they might give you results, for example, 0, 2, 1, 4, and 6, let's say. So not all data are numbers as well, right? So we could say if you again ask the gender of each of your friends, of the same 5 friends that you have asked for, so they might be male, male, then female, male, male again, right? So most data usually have in the two categories that we have, so numerical or categorical. So the numerical data mostly have the measurements such as person's height or IQ, weight, blood pressure. So or they could either be the count data as well, so such as the stock shares a person owns, then how many teeth a dog has, or how many pages you can read of your favorite book before you fall asleep. So this kind of data are actually the numerical data, and they are also called as quantitative data. Now again, so this numerical data we could say they have two types, discrete and continuous. So the discrete data represents the items that can be counted. So they take on possible values that can be listed out. So the list of possible values may be fixed or finite. So or it may go from 0, 1, 2, and on infinity, right? So making it countably infinite. So for example, the number of heads in 100-point flips takes on value from 0 to 100, right? Then So such kind of scenarios, we could say they are the discrete numbers, discrete data, and then the continuous data, they basically represent the measurements. So their possible values cannot be counted and can only be described using the intervals on the number line that we have. So for example, we could say the exact amount of gas purchased at the pump for cars with 20 gallons tanks, right? So would be continuous data. So from 0 gallons to 20 gallons. So represented by the interval between the 0 to 20, right, inclusive. So that kind of example, so we could say they are the continuous data. So because you might term like 8.40 gallons or 8.41, or we could take also numbers like 8.41, 8563 gallons, right? So or any possible numbers from 0 to 20. So in this way, we would say that continuous data can be thought of as being uncountably infinite. So, so for ease of record keeping, we usually pick some point in the number to round off. And then moving to the next step, so we have another type that we call it as categorical data. So they represent basically the represents the characteristics. So we could say the person's gender, marital status, or home type, or what kind of movies they like. So mostly this categorical data can also take on numerical variables. So for example, this one can be indicating male or the two indicating female. So but again, these numbers don't actually mathematically means, right? So you couldn't add them together. For example, the other names for cat. Uh, so one plus, so you cannot add male and female. So even if you could denote them as 1 and 2, but they would be considered as categorical data. So this categorical data are also called as qualitative data, like the numerical are called as quantitative. So this categorical data are called as qualitative data. So actually we have another kind of data that actually comes under categorical data. So they are called as ordinal data. So they mixes basically both the numerical and categorical data, and they fall into categoricals only. But the numbers placed on those categories have meaning actually. So for example, if you're rating a restaurant on a scale of 0, that is lowest, to 5, for example, that is considered highest stars. So that gives ordinal data, right? So because the 0, 1, 2, 3, 4, 5, so that is actually having some order. the 0 standing for the lowest star and the 5 standing for example, the highest star, the best rating of that particular restaurant. So this ordinal data are often treated as the categorical data only, so where the groups are ordered when any graphs or charts are made. So unlike that categorical data, the number do have mathematical meaning. So in the nominal data that we have in the categorical, so the numbers actually don't have any mathematical meaning, right? So if we consider male as 1 or the female as 2, so that can be considered as nominal data. So it doesn't have any mathematical meaning. So whereas in the ordinal data, so we have, for example, as we say that the ratings, for example, if you survey 100 people and ask them to rate the restaurant out from 0 to 5, so taking the average of the 100 responses will have a meaning, right? So this would be would not be a case with any categorical data that we have. All right, so these are the different kinds of data that we have, and so till now we have discussed the basic terminologies, then the different sampling techniques that we have, and then differential and inferential statistics. So we have seen what all different kinds of data types that we could have.